Alright, now we're going to have a look at 2016, question 9, part B. So the hydrostatics question with an immersed rod. Now this one, if we have a little look at it, it's going to be all about letters. So we are told that the density of the rod is S. We're not even told the length of the rod. We're going to give it a length called L. Conveniently, the density, it is water, so we know the relative density of water is 1. And that's about it. So we need to figure out the fraction of the rod immersed. Now this is actually a fairly straightforward question with just a little bit of funky algebra. Not even that bad. A little bit of fun at the end though. So there we go. There's a little thing here. We just get our terms laid out nice and straight. So A and B, we know that, well, we know nothing else really. So let's call this angle theta. Let's call the total length of the rod L. You can call it 2L if it makes you happy. It doesn't really matter too much. Again, the reason I'm going to go with L and X, see if you can think of it. There. It is, of course, if we look at the question, we're looking for the fraction of the length immersed. So we're looking for X over L. So our question is basically find X over L. And if I start bringing 2's into it, I'm just going to trip myself up. So there we are. We have our forces. Our weight is going down, and our buoyancy is going up. Okay, so it's a fairly standard question, just a little bit of fun at the end of it. So first of all, the buoyancy, of course, is the fraction immersed. Okay, we'll put our equation up here, SL over SO. So that is the fraction of the weight immersed. So in our case, it is X over L, because that's the fraction of the rod underwater, by W, by specific density of the liquid, which is 1 in this case, by specific density of the object, which is S in this case. So that is Wx over SL. All right, now we're going to take moments about B, which is quite annoyingly not our buoyancy, it's the B up there. All right, that's a terrible way to do it. So actually I'm going to cross that out and call it C and C, just to have something different on it. All right, moments about that point there, where it's hanging. Well, buoyancy going up, weight going down. So we have the buoyancy by this distance here, okay, which is L minus X over 2. 2 sine theta, because of course I actually want the distance between these two pens, this distance here, and that equals weight by L over 2 sine theta. All right, a little bit of tidying, we'll get rid of the sine thetas, and let's substitute our buoyancy at this stage, because this isn't too horrible just yet. So weight by X all over S over L, L minus X over 2 equals weight by L over 2. Goodbye to our weight. Now, if we look at what have we got left, we have L's, X's, and S's. Okay, so we're asked to find in terms of S, X over L. So we've got all our bits and pieces here. It's just a case of trying to solve this. So let's see what we can do here. First of all, let's multiply them out. So that one there becomes L over SL, and they're going to cancel, minus X over 2SL equals L over 2. Well, fabulous. Completely different denominators. A little bit of only 3 terms, but a little bit ugly and messy. So what we're going to do is we're going to have a common denominator to try and tidy it all up, which is going to be 2SL. All right. So we are going to have that by 2SL is going to be 2L minus X equals SL squared. Now, I'm sensing a little bit of a small mistake in here. I can see it there. That should, of course, have been x squared. Okay, so bring that x squared back in there. All right, now let's just have a little look over this, make sure we're on the right track. Did I lose that x up there? I did lose that x. That's it. Okay. So, just being a little bit careful, it was a little bit tempting to go down there and cancel the l's. Now, the reason, by the way, I spotted that is that I can see there's a little bit of a pattern. It's like two quadratics blended into each other here. Okay, so a little bit of tidying up. I like my plus x squared, so change all the signs here. We have room for another line here. Let's line that up. X squared minus 2lx plus SL squared equals 0. That's my little quadratic. Okay, now if we look at this closely, we realize that we are going to get a nice little kind of thing where we solve x in terms of L, and we're looking for x over L, so we should be able to sort it out. Now, definitely not doing that in your head, so we are looking at our formula. Minus b plus or minus the square root of b squared minus 4ac, the one you know and love, over 2a. How to make a mistake in it? Try and substitute directly. Take a little moment. A equals 1, b equals minus 2l, and c equals SL squared. Now that we know what we're doing, we're much less likely to drop a sign or something small like that. So we end up with x equals 2l plus or minus square root of 4l squared minus 4 by 1 by SL squared. Okay, so at least we're looking at the same terms. That's good. All over 2a, all over 2. Okay, x equals 2l plus or minus 4l squared minus 4SL squared all over 2. Well, we'll pull out the common term because I really want to get rid of this 2. That would be dead nice. So let's take out the 4l squared. So x equals 2l plus or minus square root of 4l squared by, just so we're clear on that one, 1 minus s. This is looking tidy. All over 2. A few more lines to go on this one. So that is equal to L. Cancel out the 2's now. Plus or minus. So 4 root of 4L squared is, of course, 2L. So that is going to be L root 1 minus S. Okay. Now, we wanted to find x over L. So this is kind of where that, small bit of trickiness here, small bit of understanding what we're looking for. So we'll divide both sides by L. X over L now equals 1 plus or minus root of 1 minus S. Okay, and that there is our answer.